Newton's first law of motion. Sir Isaac Newton was a brilliant mathematician and physicist, among many other professions. Perhaps he is most famous for his three laws describing motion and his law of gravitation. We will be covering the three laws, but not gravitation. That will be a future topic. Here's the law right up here. An object at rest remains at rest, and an object in motion remains in motion along a straight line with a constant speed unless acted upon by a net external force. Many times there are several external forces acting on an object, and that is called the net or total external force. They all add up together to determine the motion of an object. An object maintains its velocity, both speed and direction, unless acted upon by a non-zero net external force. We say those forces are not balanced. For example, if you're pulling in this direction with a force this big, and you have a force in the opposite direction that's a little smaller, well, you're going to have a net force in that direction. If you pull with the force here, and then you have the same direction, the opposite direction with the same magnitude, that is a balanced force. Here's our first law of motion again from Isaac Newton. When a force acting to the right and a force acting to the left of an object have the same size, they cancel each other out, resulting in a zero net external force. And that's what was showed on the previous slide. This also works for multiple forces as long as they cancel each other out. The forces are balanced. Now, having zero velocity, being at rest is not special. It is just one possible velocity when there is a zero net external force. A spaceship is moving through the universe at a constant speed. Once at the constant speed, it can turn its engines off. As long as there are no other forces on the spaceship, it will continue moving at that same speed. Here's a real-life example of Newton's first law. The satellite Voyager 1, which we see here, and that was the picture on the previous slide, was launched from the U.S. on September 15th, 1977 to survey the solar system and interstellar space. It is still going, as there are no external forces acting on it, at a speed of 38,000 miles per hour, which is 17 kilometers per second, at a distance of 15.1 billion miles, or 24.3 billion kilometers from the Earth. It left our solar system in August 2021 and entered interstellar space and is still moving. Newton's first law is also referred to as the law of inertia. The word inertia comes from the Latin word iners, which means idle or lazy. Inertia is the tendency of an object to resist any change in motion, like this cat over here. Here's the impact of inertia. A full coffee cup was mistakenly put on the console next to the driver. Let's see, probably over here somewhere, and it wasn't secured to the console there. The driver started the car and increased the car's velocity very quickly. The drink was at rest and required a force to start it moving. The car did not exert a force on the cup right away, so it stayed where it was. Since the car moved forward, car's going this way, and the cup didn't move, it fell backwards within the car. Here's a nice simulation of inertia. Click on this image over here, and that will launch it. Click on the Motion tab, check Speed to add a speedometer, and place a person on the skateboard. Apply a force to the object and look at the speedometer. What happened? Stop applying the force. What happens then? Which has more inertia, a tennis ball or a bowling ball? We'll answer that on the next slide. And why? The bowling ball does. It has more mass than the tennis ball and requires more force to change its motion. Mass, and this is just one definition, there are two, is a measure of how much matter is in an object. A bowling ball has more matter than a tennis ball. And what is matter? Matter is what's composed of electrons, protons, and neutrons. It's everything we see around us is matter. A bowling ball requires more effort to get going, stop, and change direction. That's because the bowling ball had more inertia than the tennis ball. And here's our second definition of mass. Mass can also be described as a measure of the inertia of an object. The larger the mass, the larger the inertia. Mass is often measured in kilograms, abbreviated kg. In most labs and problems, we will work with mass in kilograms. Sometimes we may measure or be given mass in grams, and 1 kilogram is 1,000 grams, or 1 gram is 0.001 kilograms. The European Space Agency, ESA, has a great video explaining Newton's first law, so please click here for the video.